Hello everyone, here's JJ. Now today we'll learn arithmetic sequences and series. Or maybe if we have time we can learn continue. I think it's geometric sequences. So let's review the definition. An arithmetic sequence is formed by adding or subtracting the same number to get to the next term. For example, 1, 4, 7, 10, 13 has a common difference of positive 3. And for this case, it has a common difference of negative 4. So I mean, we can, normally we use D to express common difference, because difference, the first letter is D, so yes, D. And also like common difference can be negative. Then you have something like that. I will explain it a bit. So first term, if first term we write as U1, then second term, according to the sentence here, is formed by adding or subtracting the same number to get to the next term. So if we want to get second, we have to use first term to plus common difference, which is D. Then we get something here. And here's for an arithmetic sequence with common difference D, we have UN equal U1 plus N minus 1, the D time D, the whole thing time D. So I can prove it. It's not really hard, because guys, let's see. U1 U0. Oh Jesus, I make a small mistake. Never mind. Here's not 0, here's 1. First term is 1, is U1. So U1, first term is just U1, but U1 can also write as U1 plus 0 times D, because 0 times everything is equal 0, so yeah, it's something like that. So second term is U1 plus D, which also can write as U1 plus 1D. Third term is U1 plus 2D, so we can find that. First term, 0D. Second term, 1D. Third term, 2D. So it means if nth term, we have n minus 1D. Oh, Jesus. We have to use U1 plus whole thing. That's why we can get this formula. Did you guys get it? I mean, 1, 0, 2, 1, 3, 2. So if here's n's, here must be n minus 1. Oh my god. I think I'm genius. Never mind. So here's an example. As an arithmetic sequence has first term 7 and common difference 8, find the 10th term. So we know that UN is equal U1 plus n minus 1 times D. So we just put all the data we have in here. So first term 7 means U1, remember. U1 common difference is D, which is equal 8. 10th term is the n here. So UN, so here it should be U10. U10 is equal 7 plus 8 times 10 minus 1, which is equal 79. So for this question is it's like just according to the definition and the formula, we just calculate the no matter maybe nth term, how much is the nth term, what is the how much is the common difference, something like that. Then here is something really interesting. It's about sum of the first n terms of an arithmetic sequence. Oh, it's also useful to have a formula. So the sum of the first n terms of an arithmetic sequence is sometimes it's called an arithmetic series. So here's two formula to calculate the arithmetic series. But why is like something like that? I can prove it. So for example, I will give a real example of arithmetic sequence. Okay, guys, let's see. 1, 3, 5, 7, 9. So we have 5th term, right? I mean, this five term. What can we? What we? I mean, so we have 5 term. It means here must be a middle point, which is 5 in this case, right? So we let's try to find some pattern. Then because it is arithmetic sequence, so we know that 3 is equal 5, 5 minus 2, 7 is equal 5 plus 2, 1 is equal 5 minus 2 minus 2, which is 5 minus 4. 9 is equal 5 plus 4. Now we see 7 is 2 more than 5, and 3 is 2 less than 5. So why don't we let 7 to share 2 with the 3? For 9, we will share 4. So after we do this, we will get 5, 5, 5, 5, 5. So I have a question. How many terms do we have in total? Okay, we have 5 terms. So after we share, we find that so every term will become 5. So the sum of 1, 3, 5, 7, 9 is equal to 25. Okay, I mean, this case is really special because these two numbers are all 5, but this 5 is different. So I will show another case. 1, 4, 7, 10, 13, and 16. Now this time we have 6 term. So the middle point will not be any number here, but we know that. Just imagine that here's the number, right? I mean, the average number of those number is also here because it's arithmetic series. So 7, 10, the middle point it will be let me calculate it, is 8.5. If you are not sure, you can check. 10 minus 8.5 is 1.5. 8.5 minus 7 is 1.5. And also, if you use 13 to minus this and use 8.5 to minus 4, you can get the same thing. So now what should we do? 10, we can let 10 to share 1.5 with 7. Let 13 to share how much is it? Let's see. Let me see. Is 4.5 to 4, and let 16 to share 7.5 with 1. So at the end, we find that all the number will become 8.5, and because at the beginning we have a 6th term, which means after we change everything, we still have oh my god, we still have 6th term. So the result will be 6 times 8.5, which is equal 6, 8, 48, 6, 5, 3. So it will be 51. So we know that 6 means how many terms do we have? Like, so it means first n terms. So it means n here, and 8.5. How can we get 8.5 faster? So I mean, if it is like just 5 or 6 term, we can find it we just calculate it. But if here's longer, like for example 101 terms, how can we find the middle point? Yes, use first terms plus last term added together divided by 2. We can always get the middle point. For example, 1 plus 9 divided by 2 is 5. 1 plus 16 is 17. 17 divided by 2 is 8.5. So we know that 8 so this term will be the u1 plus un then divided by 2. So guys, let's make it like so let's rewrite it. So we know that okay, we use, because it's called series. So series, the sum of first sum of the first n terms we can write as Sn. So we know that Sn is equal, how many terms do we have, like nth term? Time what? First term plus last term. Okay, sorry, here shouldn't be 2, here should be n. N time u1 plus un, then, okay, here's n, sorry, oh my god, my bad writing. Time 1 over 2, which can write as n over 2 time u1 plus un. It is the second formula. How can we prove this? If you don't understand, just ask me. And what about first formula? Remember, for the we can replace un because un can write as something related to u1, n, and d. Let's see. un is equal u1 plus n minus 1, the thing times d. So we can use this thing to replace here. So let's simplify it. It is second formula, right, guys? I mean, so these two things we can calculate. We can use both formulas to calculate series n. So it means their two are equal. So I mean, because y is 2 equal, yes, because un can use the first formula we learned to replace it. So we can get this two formula. So let's do. Okay, here's a provement here. Oh my god, he really explained everything. Jesus, good job. Let's see how do they prove it. So they really expand everything here, right? Oh, why he used a, not just u1? Hey, so never mind this a. This a, it means u1, the first term, but he used another letter to express it. So he really do everything. Let's see. Hello, and because the sum is not for this case is finitive. So for the finitive and plus, we can change the position of everything. So he just reorder everything. It's from a, the first term, to the last term. Here's from last term to the first term, but it's expressed same thing, and they add them together. But for they calculate term, like first term for both, second term for both. For example, a, this thing plus this thing plus this thing first, like for this is for the other thing is same, and after we add everything, we find that all the term is same. It's all like 2a plus n minus 1 times d. Every term will become this, because for the right side we'll add them together. For the left side we also have to add them together. So for the left side is 2Sn, and for the right side is something like we just calculate everything like that, then we get everything, and those things are same. And Sn, it means we have n's term here, so we also have n something like that. So 2Sn is equal n times this whole thing, so Sn is equal n divided by 2 times this thing. So here's a story about Gauss, right? I don't know how to pronounce his name in English, but actually here's a story about him, because I remember he and his classmate made a mistake in math class. So his math teacher asked him to count everything, to calculate the sum from 1 to 100. So when other students still calculated by hand, like from 1 plus 2 plus 3 plus 4, Gauss just get the answer is 5050, because he used the same method as what we learned today. Oh my god, use this method. First term 1, last term it will be 100. We have 100 terms, so it will be 50 times 101, which is equal 1050. So it is a really interesting story. It shows why Gauss is clever. Yes. So here's an example question, and guys, let's. Oh, I have to remind everyone of something. So we have two formula. So how do we know when should we use which? I mean, when should we use first formula or when should we use second formula? Remember, I have a tip. You can use this tip for both physics and math. So most of the time, the question will tell you something which is known. So for example, here, you see, first term is 5. So remember, first write u1 equal 5. Common difference is -2, so it means d equal 2. Okay, I will make it bigger. So find the sum of the first 10 terms. So first 10 terms, it means we also know how much is n. N is equal 10. So let's go back to the formula. So we want to get Sn, but right now we only have u1, d, and the n. For the first formula, we need n, u1, and d. We can use first formula. And for the second formula, we have n and u1, but we don't have un. Because un, if you really calculate it, you have to calculate it by yourself again. I mean, but we have the thing we know, we can just put it in the first formula and get the result. So obviously we will use first formula. So let's continue. So here, we will use the first formula to put everything in, then we can calculate the result. And for the second question, we can use same method. First term is 10 and last term is 1000, which means we know that u1 is equal 10 and un is equal 1000. Okay, they didn't tell me what is the last term, but actually here, this n is not mean, I mean, maybe we also don't know how much is n, but we know, but here, un actually means the last term. So yes, u1, we know u1 is 10, un is 1000, and there are 30 terms. Okay, no, also actually we know how much is n. So we know that u30 is 1000, but never, it's not really important right now. N is equal 30. So we know u1, un, and n. Obviously, we have to use second formula. Yes, second formula, we have already know the three things we don't know. But for the first formula, we need d. Yes, let's continue. So we put everything in, then we get the result. Yes, actually, for the arithmetic sequences, here's not a many big problem. But I mean, if you know how to prove those formula, it can make you understand more about this formula. And let's continue. So today we will learn a new sign used of sigma notation for sums of arithmetic sequences. Okay, this thing seems really scary, but I will explain. So actually so the thing here, oh my god, where's my mouse? Oh, here. So the thing here, it means the r will begin with which number? In this case, it will begin with 1. And the thing above, the sigma, it means the sum will end when r equal n. So you see, so it means from 1 to n, and all the number, if they don't mention that, all the number we use will be positive integer. So you see, this sign actually means we count u1 plus u2 plus u3, count until un. So yes, 1 to n, 1 to n. So here's something, guys. I think you can read it by yourself. So here's something here. Here's the example. So actually, this thing, it means we'll put r from 3 to 10. All the positive integer from 3 to 10, which include 3 and 10, put in this I don't know how you name that, polynomial, and then we count all the results. You see, from Jesus, stop. from 3 to 10. You see, 5r times 2, so the first term will be 5 times 3 plus 2, and second term will be 5 times 4 plus 2, then count everything until 5 times 10 plus 2. If you guys don't understand it, I can just create many example. Okay, let's create an example right now. For example, if we want to count all the square number from first positive square number to 10th positive square number, so we can write like something like that. R equal from 1, R equal 10. It means count from 1 square, 2 square, 3 square until 10 square. Oh no, guys, remember the letter here R is, we can use any letter to replace R. So but I mean the example is R, but it's not. Here's the tips. Okay, I will read this. There is nothing special about the letter R here. Any letter could be used. I will use same example, but now. So it means we will put 1, 2, 3, then put all the positive integer between 1 and 10, include 1 and 10, is until 10. So what's that? What is there's nothing special about the letter R here? Any letter could be used. It means if we use another letter, for example, I. It also means same thing for the right side. I mean, they just change a letter, nothing changed, right? So here's the example of how to use sigma. And guys, you see here something like that. Yes, that's all the things about arithmetic sequence. So actually, for the second formula for series, we have something special. How to do that? Actually, we can guess. Okay, I want to show you guys something. U1, U2, U3, U4, U5, U5. So actually, we know that U1 plus U5 divided by 2 is equal U3, right? It makes sense, right? Because U3 is the middle point because it's a arithmetic sequence. But actually, we also know that U2 plus U4 divided by 2 is also equal U3. What do I want to say? I want to say that, for example, if you know the second term is 10 and the term before the last term, we just n minus 1 is equal 1000, and you know that n is equal 30 again. How can we calculate the Sn? Actually, we can also use same formula. Similar formula. We will use U2 plus un minus 1 divided by. Okay, I will use same form, which is equals 30 divided by 2, then 10 plus 1000. Guys, I mean, I don't know how to. I will explain the reason, because actually this formula you can write as this form, right? I mean, Sn is equal n time U1 plus Un divided by 2. It's same thing, right? We just move divided by 2 here. But the thing is, U1 plus Un divided by 2 is equal the middle point. No matter who is middle point, it's middle point also in the arithmetic sequence. Because for this case, U1 and U5 we will get U3, but if U1 and U6 we will get U2 something between 3 and 4, we can call as U3.5. But so you see here, U2 and U4 divided by 2, we also can get U3. So we have two ways to get U3. So if we know the second term and the term before the last one, we can also use these two added together divided by 2, then we get U3 and use U3 to time n. So it's something extra. I mean, I don't think we will face this problem in IB, but I mean, if you know that, it's something really cool. It's something really cool. So it's all thing about arithmetic sequence.